Hey there, StudyBuds! This is your StudyBud Jeanne. For today's trip to the world of algebra, we will learn about properties of real numbers, addition, and subtraction of rational numbers with variables. Rational number. It is a number which is written in the form P over Q, where Q is not equal to 0. In other words, it is a ratio of two numbers. The reason why P over Q, where Q must not be equal to 0, is that P over Q can also be read as P divided by Q. Q cannot be 0 because we cannot divide a number by 0. Rational number can be written as a fraction, A over B, where A and B are integers. If this is to be converted into fractions, we can observe that it has a terminating decimal or repeating decimal. Examples: 1/2, 1, -3, and 0.33. Quick tip on how to convert repeating decimals to a quotient of two integers. Let x be a repeating decimal. The idea is to multiply x by appropriate powers of 10 and then subtract to eliminate the repeating part. For example, 0.1212 continuing. X is equal to 0.1212. We will multiply it by 100 because it is where the pattern starts. So 100x is equal to 12.1212. Now let's subtract to eliminate the repeating part. 100x minus x is equal to 12.1212 minus 0.1212. We will have 99x is equal to 12. Now let's divide both sides by 99. That leads us to x is equal to 12 over 99. For our final answer, we must reduce the fraction into its lowest terms. So in this case, we will divide it by 3. So our final answer will be 4 over 33. Here's another example. 0.0344 continuing. X is equal to 0.0344. We will multiply it by 1000 because it is where the pattern 444 starts. So 1000x is equal to 34.44. Now let's subtract to eliminate the repeating part. We will subtract it by 100x is equal to 3.444 to eliminate the repeating part. We cannot just eliminate it with x, which is equal to 0.0344 because 3 is beside the repeating part. So 1000x minus 100x is equal to 34.44 minus 3.44. That will lead us to 900x is equal to 31. Now let's divide both sides by 900. We will have x is equal to 31 over 900. Rational numbers would include integers. Integers are counting numbers like 1, 2, 3, and so on. Its negative counterparts are -1, -2, -3, and so on, and 0. Properties of real numbers. There may be cases that we will be using 2 or more operations. Hence, there are some properties that we need to take note of. Number 1, commutative property. The order in which addition or multiplication takes place. It is written in the form A plus B is equal to B plus A, or A times B is equal to B times A. For example, 3 plus 5 is equal to 8. 5 plus 3 is equal to 8, which means 3 plus 5 is equal to 5 plus 3. Another example, 2 times 3 is equal to 6. 3 times 2 is equal to 6, which means 2 times 3 is equal to 3 times 2. Associative property. The way we add or multiply three real numbers will not affect the final result. It is written in the form open parenthesis a plus b close parenthesis plus c is equal to a plus open parenthesis b plus c close parenthesis is equal to a plus b plus c. Or open parenthesis a times b close parenthesis times c is equal to a times open parenthesis b times c close parenthesis is equal to a times b times c. For example, 2 plus open parenthesis 3 plus 4 close parenthesis is equal to 2 plus 7 is equal to 9. Open parenthesis 2 plus 3 close parenthesis plus 4 is equal to 5 plus 4, which is equal to 9, which means 2 plus open parenthesis 3 plus 4 close parenthesis is equal to open parenthesis 2 plus 3 close parenthesis plus 4. Another example, 2 times open parenthesis 3 times 4 close parenthesis is equal to 2 times 12 is equal to 24. Open parenthesis 2 times 3 close parenthesis times 4 is equal to 6 times 4, which is also 24, which means 2 times open parenthesis 3 times 4 close parenthesis is equal to open parenthesis 2 times 3 close parenthesis times 4. Take note, the difference between associative property and commutative property is that in commutative property, the order changes. Meanwhile, in the associative property, the grouping changes. 3. Distributive property. If a term is multiplied by terms in parentheses, we need to distribute the multiplication over all the terms inside. It is used to remove parentheses and to combine two expressions. It is written in the form a times open parenthesis b plus c close parenthesis is equal to ab plus ac, or open parenthesis a plus b close parenthesis times c is equal to ac plus bc. For example, 2 times open parenthesis y plus 3 close parenthesis is equal to 2y plus 6. Another example, 10 times open parenthesis 3 plus 5 close parenthesis is equal to 10 times 8, or 30 plus 50, which is both equal to 80. 4. Identity property. The identity property for addition tells us that 0 added to any number is the number itself. 0 is called the additive identity. The identity property for multiplication tells us that the number 1 multiplied to any number gives the number itself. The number 1 is called the multiplicative identity. It is written in the form 0 plus a is equal to a plus 0 is equal to a. Or 1 times a is equal to a times 1 is equal to A. For example, 4 plus 0 is equal to 0 plus 4 is equal to 4. Another example, 3 times 1 is equal to 1 times 3 is equal to 3. 5. Inverse properties. It states that adding a number and its inverse results in a sum of 0, and for multiplication, multiplying a non-zero number with its inverse results to 1. The additive inverse of 8, that is often called the negative of A or the opposite of A. The use of such terms can be dangerous because they suggest that the additive inverse is a negative number, which may not be the case. For each non-zero real number A, there is a real number called the multiplicative inverse of A, having the following property. A times open parenthesis 1 over A close parenthesis is equal to 1 over A times A is equal to 1, which means that A is not equal to 0. For example, what is the additive inverse of negative 8? It is 8 because negative 8 plus 8 is equal to 0. Another example, what is the additive inverse of 6? It is negative 6 because 6 plus negative 6 is equal to 0. What is the multiplicative inverse of 1/2? It is 2 because 1/2 times 2 is equal to 1. Last, what is the multiplicative inverse of 3? It is 1/3 because 3 times 1/3 is equal to 1. Addition and subtraction. When adding or subtracting real numbers, imagine moving to the right of the number line when adding and moving to the left when subtracting. For example, 3 plus 9 is equal to 12. We have another example here. So 3 minus 9. So from 3, move 9 units to the left of the number line, which results to negative 6. Another example, negative 3 plus 9. From negative 3, we move 9 units to the right of the number line. So negative 3 plus 9 is equal to 6. Last example, negative 3 plus negative 9 is equal to negative 12. Adding rational numbers. Rule 1. Adding two numbers with the same sign. To add two numbers that have the same sign, either both positive or both negative. First, add their absolute values. Second, give the sum the same sign as the sign of your addends. Example 1. Add negative 13 and negative 26. Add their absolute values, so 13 plus 26 is equal to 39. The sign must follow the addends. That's why our final answer must be in a negative form, which is negative 39. Example 2. Add 0.3 plus 2.634. Add the absolute value of 0.3 and 2.634. So that will be 0.3 plus 2.634, which is equal to 2.934. So the sign must follow the addends, and that's why our final answer is still in the positive form. Rule number 2. Adding two numbers with different signs. To add two numbers that have different signs, first, find their absolute values. Subtract the smaller absolute value from the larger. Second, give the result the same sign as that of the number with the larger absolute value. For example, add 14 and negative 72. Subtract the absolute values of negative 72 and 14. 72 minus 14 is equal to 58. The sum is negative since the absolute value of negative 72 is larger than the absolute value of 14. Example number 2. Add negative 3 over 4 and 7 over 2. So first, we must change this dissimilar fraction to similar fraction by finding their LCD. Their LCD is 4. Now, let's subtract their absolute value. 14 over 4 minus 3 over 4 is equal to 11 over 4. So the sum is positive since the absolute value of 7 over 2 is larger than the absolute value of negative 3 over 4. Reminder: to add several numbers that have different signs, you can add the positive and negative numbers separately and then add the two sums. Example: negative 4 plus 18 plus negative 40 plus 2. So first, let's add the positive numbers separately from the negative ones. So 18 plus 2 plus negative 14 plus negative 40. That will lead us to 20 plus negative 44. Our final answer will be negative 24. Subtracting rational numbers. For all real numbers m and n, m minus n is equal to m plus negative n. This means that any subtraction problem may be written as an equivalent addition problem. The rules for adding numbers can then be applied. Example 1. 3 minus 9. 3 minus 9. So first, let's change the expression to its equivalent addition problem. 3 minus 9 is equal to 3 plus negative 9. The answer is negative 6, since the absolute value of negative 9 is greater than the absolute value of 3. Last example. Subtract negative open parenthesis 12 minus 89 close parenthesis minus open parenthesis negative 9 minus 23 close parenthesis. So first, operations within parentheses must be done first. So 12 plus negative 89, which is negative 77, then negative 9 plus negative 23, which is negative 32. Now let's distribute the signs outside the parentheses. That will lead us to 77 plus 32. Our final answer is 109. That's all for today's study buds. See you next time!